Hello friends, we will see how probability is affecting our day-to-day life. We used to talk probability of raining is that types of problems will be encountered here. We will just develop the basic concept of probability, and I say that is not the basic, that is the only concept we will be developing today. And that concept is probability of any event is favorable outcome by total outcome. That is the basic definition and the only definition. Total outcome, what in total can be, and favorable outcome, what we want. Suppose I'm just throwing a die. Okay, what is happening? Total outcome is 6. It can be either 1, 2, 3, 4, 5, 6. And if I want, or I have to find the probability of getting an even number, what are the favorable things? Either 2, 4 or 6. So number of the favorable thing is 3 here and the total outcome is 6. So the probability will be 3 by 6. That is 1 by 2. That is very basic thing. Suppose in a class 6 students are there, out of which 4 are boys and 2 are girls. Okay, I have to select one student which is happening to be a boy. That means find the probability of selecting a boy from 6 students. So favorable outcome here is 4 and the total outcome is 6. So probability is coming out to be 2 by 3. In this way, we have to find the probability of any event. Now we will see what the meaning of the event is. What is an event? Event means anything happening. Now we will see if 2 events are happening, what is the relation between these 2 events? Either they will be exhaustive event. What is the meaning of exhaustive event? See that if an event is happening in this fashion and the remaining part of the event of the total sample space is happening in y ways and total number of probability of x and y is 1, then they are called exhaustive event. What does this mean? Only x and y is making the completion of the event. In this case, if a die is thrown, we throw odd numbers. If is one event, it is coming out to be 1 by 2. Throwing even numbers is another event, that is also coming out to be 1 by 2. And now the sum of both the event is making 1 total event, odd or even. So these 2 events are known to be exhaustive event. We will be dealing with such type of terms in next level of problem solving. Another thing is mutually exclusive event. Mutually exclusive means they are not dependent on each other. Suppose a coin is tossed, either a head can come or a tail can come. Coming of tail is independent of head, and coming of head is independent of tail. Same way, if we throw a dice, even number is coming or odd number is coming. They are independent of each other. That means they are mutually exclusive events. That is the basic definition about the event. Now we will see what is odds in favor and what is odds against an event. That we will see. Odds in favor of any event, I just say in local language, chance of winning by chance of losing. That means chance of happening of the event divided by chance of non-happening of the event. Happening and non-happening are mutually exclusive. If happening is PE, then non-happening is 1 minus PE, and that is termed as PE dash, complementary of that. Because they are mutually exclusive. Either it will happen or it will not happen. So happening by non-happening is odds in favor. odds against an event, odds against is non-happening by happening, and non-happening we know 1 minus PE by PE, that is odds in favor, odds against an event. So we can find these things, odds in favor and odds against an event. The basic problems we will be seeing for finding the probability is you just see what the total outcome is there and what you want is the favorable outcome. Suppose 2 dice are thrown. What is the total outcome? It is coming out to be 36. That is total outcome. Firstly, just go for finding out total outcome and then go for finding out the favorable outcome in all the type of questions. That is my recommendation. Suppose I want the sum to be 9. So what will be the favorable outcome? It can be 9 can be made as 3, 6, 6, 3, 4, 5, 5, 4. That's all. Only 4 possible ways are there when the sum of the numbers appearing on the 2 dice is making 9. So the favorable outcome here is 4 and the total outcome is 36. So the probability of throwing 2 die and getting the sum 9 is favorable is 4, total number of favorable outcome by total number of possible outcome, that is coming out to be 1 by 9. So the basic definition we will be following to find the probability of any event as favorable outcome by total outcome. Hope you are understanding the basic definition of probability. Now we will solve the problems of probability related to permutation and combination. Just 2 rules we will develop here, and is always standing for into and or is standing for plus. Just keep that thing in brain. Your problem solving will be enhanced. You can solve the problems very easily. Now one particular question I am taking, that out of 52 cards we are selecting 4 cards. What is the probability of, question number 1, all being red? See, all being red. I have said you all the time, firstly you find total outcome. Total outcome is here 52C4. Just that is very simple to find the total outcome. Out of 52 cards I have to select 4 cards. Now favorable cards, favorable event. That means all the 4 cards are to be red. 26 red cards are there. So out of that 26 we have to select 4. So 26C4 is the favorable outcome and 52C4 is the total outcome. So this is the probability. Suppose I have to find 2 red, 2 black. Total outcome is not going to change. That is remaining 52C4. Not a problem. Now 2 black and is here. So into is here. 2 red. That means 26C2, 2 red and. So into, because and is there, the work is not complete. Unless the work is not complete, you have to just keep on multiplying. Because 4 cards have not been selected. Only 2 have been selected. Once the 4 cards are selected, the work is over. And 2 black, 26C2. Suppose the question is either 4 are black or 4 are red. That means either 4 black or 4 red. I said you total outcome is not going to change at all. So all the time it will be 52C4 because we are selecting 4 cards. Either 4 blacks. If we just translate that thing in English, we will write or 4 blacks or 4 red. 4 blacks means 26 C4. The work is complete. The 4 cards have been selected. So no into plus, either this way or that way. And 4 red cards can be selected in 20C, C4. That is the thing. I am just developing the concept of plus and into here, where to go for multiplication and where to just go for adding, and you will find that. Suppose I am just writing 4 cards are to be selected, 1 from each suit. We know that total outcome is remaining same, 52C4, not a problem at all. 1 card from each suit. We know that 4 suits are there in a bundle of 52 cards. From each suit we have to take out 1 card. So it will be translated like this: first card from one suit, and second card from other suit, and third card from another like this. So 13C1, work is not complete because 1 card have been selected. Dot 13C1, another card from second suit, into 13C1 into 13C1. So that is the favorable outcome by total outcome. Suppose in next question I'm just writing 4 cards are selected and 2 king and 2 queens. We have to select 2 king and 2 queen. Total outcome is remaining same, that is 52C4. 2 kings, how many kings are there in total? We know that in each suit 1 king is there, so in total 4 kings are there. So out of that 4 king I have to select 2 king, and the work is not complete, so into 4 queens are there, out of 4 queens I have to select 2 queens. So that is the required probability. So by means of this question I just try to clarify how to put the into sign and how to put the plus sign. Hope you are understanding. We will see now what is addition rule of probability. The basic formula we will be using is P A union B is equal to PA plus PB minus PA intersection B. If A and B are mutually exclusive events, we know that nothing is in common, so this will be 0. We can easily write PA intersection B 0. If 2 events are independent exclusive events, we also know that PA intersection B is PA into PB, happening of A into happening of B. That is P, either A is happening and B is happening, and the meaning of this is at least one of them is happening, either A is happening or B is happening or both are happening. The meaning of PA union B is at least one. A intersection B is both. Now one particular problem I am discussing here. If a problem of mathematics is given to 3 students A, B and C, and their probability of solving the event is 1 by 2, that of B is 1 by 3 and that of C is 1 by 4, like this. That is given in a class and 3 students. What is the probability that problem is solved? What is the meaning of that? We should understand first. If any one of the student is solving the problem, we say that the problem is solved. That means we have to write either A is solving the event, or B is solving the event, or C is solving the event. And the probability of solving the events by 3 students are mutually exclusive. That means not dependent on each other. So either this or this or this means total event Total because they are exhaustive event. Only 3 students are there. PA plus PB plus C, PC, exhaustive event. So total event, that is total probability minus neither is solving. So out of the probability, if we just subtract that nobody is solving the problem, means somebody is solving the problem, and that is the thing we want, that problem is solved. Nobody is solving problem means A is not solving problem and B is also not solving the problem and C is also not solving the problem. So it is coming out to be 1 minus PA dash is actually 1 minus PA. Why? The PA and PE dash are mutually exclusive. Either he will solve or he will not solve. Total sum is 1. So this is 1 minus 1 by 2, that is coming out to be 1 by 2, into P dash is 1 minus 1 by 3, that is 2 by 3, and PC dash is 1 minus 1 by 4. What is that? 3 by 4. So that is coming out to be 1 minus 1 by 4, that is 3 by 4. If the question is said in this way, that exactly one student is solving the problem, we have to translate it first. Exactly one is solving the problem. What does this mean? This means that A is solving the problem, but B is not solving the problem and C is also not solving the problem, or B is solving the problem and A and C are not solving the problem, or C is solving the problem and simultaneously A and B are not solving the problem. Then only exactly one will solve the problem. P A dash into P B dash. So just make this approach. You just understand what they are asking. You translate accordingly and your thing will be done. Probability is not that much tough. It is very easy. You just put it here. PA is 1 by 2. PB dash will be 2 by 3, you know, and PC dash will be 3 by 4. Like that, you just put the values and you will get that exactly one is solving the problem. If the problem is that 2 persons are solving the problem, exactly 2 are solving the problem, you have to translate A and B solving the problem, C is not solving the problem. That means PA into PB into P side C dash plus B is solving, A and C not solving, B and C are solving, A is not solving. Like that, you just translate the thing and you put the value, you will get the things done. Hope you are understanding this multiplication theorem and that union theorem. We will see now conditional probability. Probability of happening of an event when it is dependent on the other event. How we write? P A intersection B, when A and B are dependent on each other, is written as P A into P B when A has already happened. So this is the dependent problems formula for happening them simultaneously. Both are happening because the dependent of B is there on the happening of A. That we will see in the problems. See in this question, a bag contains 5 white, 7 red and 8 black balls. 4 balls are drawn one by one. Find the probability of getting all white ball. Firstly, we have to translate that what we want. We want the drawing of 4 balls and the 4 have to be white, all the 4s to be white. So the translation required probability will be first white into second white into third white into fourth white. So all the four balls have to be white. Now first white, how many whites are there? 5 C1 and total is 20 C1. Now see, now one ball has been drawn. So now we are left with only 19 balls, out of which 4 are white because one white have been drawn. So out of 4 white we can draw one in this fashion and 19 balls are left. This is favorable outcome by total outcome. The favorable possibilities by total possibility. Now how many white balls? 3 balls are left and the total number of balls are not 19 now, it is going to be 18. So 18 C1 into, now the last ball, how many options? 2 options are there, 2 white balls are left over by 17 C1. If we just simplify this thing, we can easily get, that is 5 by 20 into 4 by 19 into 3 by 18 into 2 by 17. So we can find the probability of drawing all the 4 white balls. In question number this, we see that 2 balls are drawn from an urn containing 2 white, 3 red, 4 black balls, one by one without replacement. That means one ball is drawn and then thrown away. Okay. What's the probability of at least one ball is red? We have developed the concept of finding at least one. At least one means 1 minus none. So we follow the basic concept, 1 minus none is red. If out of total probability we just rule out the probability that none is red, that means at least one will be red. So how to do? 1 minus none is red, that means first is non-red and second is also non-red. We will write first ball non-red and so into second ball also non-red. So now just see, how can I draw a ball which is non-red? Non-red balls are 2 plus 4, 6. 6 by total 9. Now one ball has been drawn and thrown. So we are left with 5 non-red, out of which total balls are 8 now because one ball has been thrown. So that is the probability of at least one is red. We can just simplify this thing, that is 72 minus 30 divided by 72. It is coming out to be 42 by 72. We can find the probability. Sometime the problem is asked like that. 2 bags are there, bag 1 and bag B. It is containing 2 white, 3 black. It is containing 3 white, 4 black. Now they say one ball is transferred from bag number A to bag number B and then one ball is drawn from bag number B. What is the probability of coming out to be white ball? So you have to translate it firstly into mathematical language and then find out. One ball is transferred. It can be one white from bag A. White has been transferred. Now the combination here is becoming 4 white, 4 black. Now from bag number 2 I have to draw one white ball. One white ball. So the probability is consisting of 3 events. First event, the changing here, the sample space is changing here and now we have to draw from here. So one white from bag A, it can be transferred in 2 by 5 ways because 2 white are there and total balls are 5. Into, now one white ball I have to draw, the combination is like this. So white ball can be drawn in 4 by 8 ways. This is the case number 1. Case 2 can be that one black ball transferred black from bag A. What is the combination becoming here? White is remaining 3, but black are becoming 5. And we have to find the probability of drawing one white ball. See here, one black. Black can be selected in 3 by 5 ways. Now I have to draw white ball from the second bag. It can be done in, you see, 3 white are there, 3 white, and total is 8 by this. So the total outcome, either what we want will happen in this way or that way. Or means we have to add up both the probabilities. So the total probability will be either this is coming out to be 8 by 40 plus it is coming out to be 9 by 40. So this is coming out to be 17 by 40. That is the required probability. Hope you are understanding that multiplication theorem, the conditional probability, how the sample space is changing and applying it. I just recommend you translate the events correctly. Once the translation is done, you just write the mathematical thing for that and your thing is done. An application of Bayes theorem in dealing with total probability problems. A toy manufacturer company is there, got 3 units, A, B and C. It is manufacturing 200 toys per day. This is manufacturing 300 toys per day and this is manufacturing 400 toys per day. In a particular city, 3 units are there and it is the record of unit A that 2% of the toys are defective. That means out of 100, 2 toys are defective. That is understood. That is the record of the unit. Here 3% toys are defective. That is the record. And here suppose 4% or 5%, 4% is defective. Now at the end of the day, all the toys are taken to a big ground, a big unit. How many toys? 500, 400, 900 toys. Okay. And then a supervisor is coming, an inspector is coming to check the quality of the toys. He is picking up a toy. Suppose he is picking up some toy and it is found to be defective. Now the question arises, from which plant this toy has come? If we directly go to plant number A, 2% are defective, that we already know. But here all the toys are mixed and now we have to find the probability from which plant it has come. That is the basis of the Bayes theorem. Just I'm writing the theorem. You just remember this, very easy to remember. P E3 by A is equal to P E3. Very easy to remember. I am just writing. You just see the pattern into P A by E3 divided by total. Total means P E1 into P A by E1 plus P E2 into P A by E2 plus P E3 into P A by E3. Very simple to remember. Suppose I am saying what is the formula for P E2 by A? That will be P E2 into P A by E2 and in the denominator total. No problem in the denominator. If I ask E1 by A, this is P E1 into P A by E1 and denominator is same thing. What is the meaning of E3 by A for this particular problem? A is standing for particular event. What is here in this question? Defective toy, defective item. E1, E2, E3 represents 3 units, 3 plants where toys are manufactured. So we need to find that it is defective, it is known. The inspector has picked up the defective item. Now what is the probability that it has come from plant number 3? Or if we need to find P(E2 by A), what is the probability that it has come from plant number 2? It is already known, it is defective. So we apply this theorem. Very easy to just remember the formula and apply this. For particular problem, I am just finding here. So it will come out to be P(E3 by A). P(E3). What is the probability of toy being manufactured in plant number 3? So the basic definition of probability, the favorable outcome by total outcome. So probability of toy being manufactured in plant number 3 is 400 divided by total is 900. Very easy. Into A by E3. Just notice the difference between E3 by A and A by E3. A by E3 means we are inside the plant number 3. That we know that it is known. A by B, you already remember in conditional probability. A by B means B is known. We have to find the probability of A. Here, E3 is known. That means we are in the plant number 3. What is the probability of being defective item in plant number 3? And that is given 4%. So that is 4% means 4 by 100. Yes? It's no need of finding how many items are defective because we are finding the probability, the favorable by total. So only write 4 by 100. Don't try to write 4 by 100 into 400. We are not interested in number of items which are defective. The probability of part being defective in plant number 3. Now write in the denominator the complete thing. P(E1), you can easily write 200 by 900 into 2 by 100 plus this is 300 by 900 into 3 by 100 plus this is 400 by 900 into 4 by 100. Very easily you can find the problem. The very important thing is you just identify the 3 events. What is happening? Sometimes it's given that the happening of the 3 bags, 3 events is equally likely to happen. In that case, suppose I just pick up 3 cases, 3 bags are there which contain 2 white, 3 black, 3 white, 2 black, 3 white, 3 black, like that. A ball is picked up and found to be black. What is the probability that it has come from bag number 2? Can you frame? It will be P(E2 by A). We need to find black ball. It is known that it is black. What is the probability that it has come from bag number 2? So you just write the theorem. It will be P(E2 by A) is P(E2). What is the E2, E1, E3? 3 bags. And they are equally likely to be picked up. So probability of picking up the bag is 1 by 3 in each case. So P(E2) is 1 by 3 into PA by E2. That means black ball from bag number 2. So this is 2 by 5. Very simple, and write in the denominator total thing. Hope you are understanding Bayes' theorem. Very simple. Just remember the theorem. You apply this. One prerequisite is understanding of the conditional probability that you have already understood.